tell you the most important things you need to know about energy for industry, and importantly, how do we decarbonize our energy for industry? So, the industrial sector is the largest energy end use sector, depending on how you look at it, but this is looking at world total final energy consumption. So, thinking of that as the energy end use. And the industrial sector is about a third of that. So, a very big energy user in terms of making a lot of the consumer products that we need, our construction materials, all of the things that we're using in our economy that we're making in our industrial sector. So, this includes everything from paper to steel to concrete to clothes, all of that is in this industrial sector. But a lot of times, the way we're using fossil fuels, which are the source of like our carbon emissions and our air pollutants from the industrial sector, there are two big ways we're using it in the industry. We use it for energy. So that's often for heat, but also can be for electricity in the industrial sector. And we're using it for feedstocks. So feedstocks are things that are actually going into thing. You often think about like natural gas being used to make fertilizer. When we're talking about decarbonizing industry, we're really focused on the energy piece. When we put it in feedstocks like a fertilizer, it's not a direct carbon emission in the industrial process. We might have emissions we worry about later when we're using the fertilizer, but when we're talking about the decarbonization of industry, we're really focused on this energy part or places where CO2 is emitted from chemical processes, not necessarily from fossil fuels. So I'm just going to try to give you a way to think about how can we think about the challenges with decarbonizing industry? What are some of the key sectors? And when you're reading media or something about it, you really kind of have a framework for thinking about industry. The three big parts of industry that are often highlighted as places that are difficult to decarbonize are the iron and steel, so those are related, and the cement industry. Both of those processes are very carbon intensive processes, the way we do them today. And it's not just the heat, there's other emissions of CO2 just in the way that we're doing those processes that emit CO2. So it makes them difficult to decarbonize. So let's focus in on these really quickly. So for producing steel, coal is one of the feedstocks for steel, both as a feedstock and as a fuel for the heat. For the fuel for the heat, we can do things to replace that. We can use other things to create that high temperature heat. And startups, others are trying to make that green steel more commercial. Right now it's more expensive, but they're trying to make demand for green steel more commercial. And then using coke or that coking coal as a feedstock, that's a much harder place to replace it, but there are options that different companies are looking into. So 70% of our steel today is produced using coal. Green steel is really a very minor piece, but we are seeing interest from companies and actually buying green steel. Concrete is the other one that I mentioned. It's about 8% of global greenhouse gas emissions. This is just showing you the very complicated process to create concrete, which is cement is the major component of concrete. So there's two different ways, again, where you're having carbon emissions, both in the coal providing the heat or other fossil fuels providing the heat needed in the cement kilns. And then also just in the CO2 emissions with the aggregate and the chemical emissions that are happening with the concrete. So you have to approach these two different CO2 emissions differently. Alternative heat sources, so like electrification or green or blue hydrogen, so decarbonized hydrogen are options, and also changing the aggregates that are used in our concretes. These are approaches to look at how do we reduce carbon emissions from these very challenging sectors. So that's just to give you a flavor. I want to take a step back and just say, well, just in industry in general, not just these hard to decarbonize sectors, how do we approach decarbonizing it? Because some of it is relatively easy to decarbonize, but it's not necessarily happening. So how do we think about it? And so if you want to decarbonize industry, you can decarbonize by changing how you're getting, especially the heat for your processes. And you can also reduce energy demand. You can be more energy efficient in the industrial process. So when we're thinking about decarbonizing, we're thinking about electrifying our process heat, and then you can decarbonize those electricity sources. So that is a great strategy for decarbonization. For places that need high temperature heat, especially, you can think about decarbonizing the fuels, like I said, using a green or a blue hydrogen, and then carbon capture and storage, which is a pretty expensive way, but also is a strategy for decarbonizing industry. And then you can reduce energy demand, and a lot of these pay for themselves. These are the things you should probably be doing anyway because it also lowers costs while lowering energy demand. Some of these things include recovering waste heat, design and pumping systems to reduce friction, variable speed drives. And so I'll kind of give you a flavor of the impact of some of these processes. So let's talk about heat for a minute. Heat is one of the big places we're using our fossil fuels in industry, and there's a big difference between the temperature demand for that heat. So how hot is it, high heat or low heat processes? So everything from the high heat, things like iron and steel, the very high temperature demand on that heat, to things like paper, where we're still often using natural gas to dry paper, but it's a pretty low temperature process. And so that one should be easier to decarbonize than some of these high heat or high temperature places. So we can electrify our process heat. We can use industrial heat pumps. So I'm showing some basically heat recovery systems behind me that are kind of at the industrial scale. We use heat pumps in our homes for space heating. So for low temperature processes, heat pumps are a great strategy for decarbonizing heat demand. And so what I'm showing you here in this chart is for low temperature needs, both in space heating and in the industry, heat pumps really make sense. It's a really easy decarbonization strategy. It gets much less efficient when you're looking at high temperature needs and may not even be able to get to some of the really high temperature needs that we need. So we have to have other strategies for decarbonizing high temperature heat. These are a lot of different options, but electric arcs are one for example that are being looked at for the high temperature needs for steel production, for example. So we have strategies. A lot of them are kind of in the development stage. They're not widespread. So why is it so important to think about electrifying these low temperature heat rather than just replacing? Like if we're using a low temperature heat service, why not just replace the natural gas with something like hydrogen? It's much more efficient to use our renewable resources or our nuclear resources, our decarbonized electricity resources to power something like a heat pump that's very efficient than it is to create green hydrogen and use hydrogen to provide those low temperature applications. So when we're really thinking about where would a green hydrogen or something fit into the decarbonization, it's going to be at those high temperature places that are harder to electrify, where it might find some markets in order to decarbonize industry. So an example of that high temperature heat need is in our steel. So like something like blue or green hydrogen, you can, instead of electrifying our heat service, you can decarbonize the fuel that's providing that heat. I think this is still very much a race. There are companies that are looking at both, using something like the arc heat for electricity or green or blue hydrogen in order to do this decarbonization of these high heat needs. You can also recover waste heat. And I'm just giving you an example of cogeneration here. But if you can recover waste heat and use that for these low temperature heat needs, that's obviously great. And so here at the Stanford campus, we do this where we are capturing the waste heat from cooling spaces and using it to heat other spaces that have a heating need. Those are all low temperature, relatively low temperature needs, and you can move the heat around. And moving heat around is much more efficient. In industry, there is often waste heat from a high temperature need. Like if you need steam for a process, like in this cogeneration example, after you've used that high temperature steam, you have low temperature steam or high heat water. You can use that for district heating, space heating, other industrial processes, agriculture, things like that. The challenge with recovery of waste heat is that you have to have the use for that heat relatively close to where you're producing the heat. We lose a lot of heat when we move it really far. And so like on a campus like Stanford, that's close enough to where we're moving the heat around, but you couldn't move it as far as something like electricity where we're moving it over, an entire continent. You can reduce energy use in industry by just designing our piping systems in a smarter way. Our piping systems are often designed with right angles. That's just kind of for ease of design, but that is a high friction way of moving fluids around. And so we can reduce the energy needs from our pumping systems just by having Ys rather than Ts, or diagonals rather than right angles in our piping systems. This would just take a rethinking of how we're designing our industrial systems. Another thing that we can do that's a big one in industry is changing how we design our pumping systems in terms of the pump and how we're controlling the flow. So in our industrial processes, we often have large fluid flows and we're controlling them oftentimes with a pump that's pumping as hard as it can and a control valve downstream of it that is controlling the flow. From my experience in industry, oftentimes that pump's pumping as hard as it can and the control valve is barely open to try to control the flow. This is a very inefficient way to do it. Variable speed drives on the pumping system, so variable speed motors or variable speed drives can allow us to vary the pumping rather than controlling it with a control valve. And this dramatically reduces the electricity demand for moving our fluids around. So we get the same service, we're still getting that pumping service, but we're using a lot less energy to do it. And so this chart here just gives you a sense of how much electric motors are really a huge share of the electricity consumption in industrial processes. And so this is a huge opportunity in order to reduce that electricity demand, reduce costs, and actually have better control of our flows, fewer replacements of control valves. There's lots of co-benefits to replacing our electric motor drives with variable speed drives. Finally, I mentioned carbon capture and storage, and I'm kind of leaving it till the end because this tends to be the kind of the highest cost way of decarbonizing a lot of these sectors in industry. But because some of the emissions from these high carbon emission industrial sectors is pretty high, you can do carbon capture storage more cost effectively than something like direct air capture or some other technology where you're taking it out of the air. So this is an opportunity. It is done in limited cases. We know how to do it. It just tends to be pretty high cost. So it is not often done. I would say the efficiency first, decarbonization and electrification as much as we can. Carbon capture and storage should kind of be that last piece of things that we can't fully decarbonize. Okay, so I hope that gave you a way of kind of thinking about decarbonizing industry. I encourage you to go to our website if you want to learn more. We have kind of a guest lecture that talks about decarbonizing industry, and of course, join our Energy Spotlight.